without further ado, I'd like to introduce Dr. Ajay Dholakia. He is with Lenovo, and he's going to be speaking to us about machine learning and AI analytics in a big data environment. So, Ajay, please.
All right, thank you, Leo. Good morning again. Hopefully some coffee is in the system now, and we can continue what has been a very interesting morning so far. In terms of being able to be heard in the back, it's okay? Perfect, thank you. I'm with the Lenovo's data center group, working as solution architect for our big data and our AI solutions. One of the other areas I also look after is healthcare related solutions. And I think both of these other topics are sort of enabling a lot of healthcare. Just a couple of quick words about me. I have been with Lenovo 2.5 years now. Transitioned over from IBM. So have 19 plus years at IBM, half of which I spent in Zurich, Switzerland at the IBM Research Lab, working on various areas in data center, storage, compute, communication, and so on. Last couple of years have been in enabling solutions. So the business unit that I'm part of course, is doing data center, servers, and storage networking. And my role is to work with our vendor partners and bring on their software stacks onto our hardware and create the right sized solution. So that's what I mean by solutions. One other quick note, as Steve introduced Leo and mentioned virtual bridges, it sort of started playing in my mind. I think my neurons were firing, and then I realized that I had actually worked with him back in those days. When I was at IBM, we were trying to bring in the virtual bridges VDI stack into our portfolio. So, small word here. What I thought we would do today is just give a little bit of a background about the industry. You've heard a few variants already in the couple of interesting talks this morning. And the angle from which I am coming at this is looking at it from a larger context of the big data systems. So while we are all excited about machine learning and deep learning in particular, and how it's going to be the driving force behind a lot of the accelerated compute, and that's the last time I'm going to say that. I think listening to Leo, I'm going to just start saying compute, right? How that's going to be all being fired up by that. But I want to step back, and as we talk to customers who are looking to deploy this, the context actually helps. So that's sort of the focus that I have in mind, and we'll speak to an example and so on. So hopefully you can see the flow, and then I think we'll follow the format where we'll do the Q&As at the end. Okay, not surprising, every industry you can think of now is working on already adopting some leading players within each industry. AI in general, machine learning more broadly, and maybe even thinking about deep learning. This is now a real phenomenon that's here to stay. In fact, across the different industries, you see healthcare, you see finance, you see retail, manufacturing. One of the ones I don't mention maybe explicitly is academia and public sector as well. We have been talking with customers who are very interested in figuring out how to bring in these new technologies into the fold within their enterprise IT architecture. So it's in some sense roll back maybe 6 years ago, and cloud was in that situation. Roll back 3 years ago, and maybe big data was in that situation. So you see that the third wave, and these waves are running into each other. As we were talking during the break, I think that the cloud and the big data and AI machine learning is certainly coming together. The questions we get are ranging from very specific solution for a particular deep learning problem that they're trying to solve, all the way up to how do I bring it into my enterprise. And so that's sort of the context that kind of got me thinking. It's also exciting to be at the start of this hockey stick. It's, you look at any of the industry analysts, we are all who plan to having and continue to plan to work in the area of AI machine learning stand to benefit over time, because this is where a lot of the IT spend is going to be in the next 8-10 years. Here's one example of a survey, but I think you can find many others that are driving us. So this started to get me thinking, how do we sort of tackle this problem? So yes, we get it, machine learning is everywhere. No matter who you talk to, they say, yep, we're doing machine learning. You have to talk for a while, maybe a couple of drinks, and then you figure out what exactly are they trying to do. And it's not that they are lying or anything, it's just such an attractive value proposition to bring it into your enterprise. What I'm showing at the bottom here, the picture is just, it's not meant to be read, but just to give you a visual that when you look at machine learning or other AI, particularly like speech and natural language processing, there are many, many, many companies working in this. So it's a very busy sort of area where there is a lot going on. And you may have to really spend some time thinking about what's really the right way for me to engage in this space. And there could actually be multiple ways. That's sort of the point on the chart here, is that you could be looking at standalone systems. You could be looking at APIs, or you could be looking at potentially embedding it into other applications that you may be developing. So that's sort of where state of the art is. The thing to then step back is, well, keep that block in mind with the 3 titles, and I step back and I plug it back into a larger context of analytics. And you notice that the red circle is what we were looking at on the previous chart. So this starts to now grow bigger and bigger in terms of what the context is. So you see BI platforms, you see statistical computing, you see a whole host of things that are sort of surrounding this. So my tagline for this is, AI is the new BI. So there we have it. Leo said, I guess I will say it one more time. Accelerated computing is just computing. So here is another tagline. AI is the new BI. And I was trying to play with the words a little bit, and I'm sure you get it, right? A program might be looking at the text color of that string. AI is the new text color of that string, BI. And the question that came to me is, how long would it take for an AI system to really actually figure out the meaning that pops into our head right away? So, humans still got it, but the developers in this world, I'm sure are inspired to go and keep working to make these systems from a natural speech language processing perspective. But I think the point is, jokes aside, the point is that this context is even bigger when you embed and start thinking of AI, machine learning, deep learning as the new next generation analytics that will be permeating the enterprises. One more time through this. And now you see that the chart we were at was here, a couple charts back. This was the analytics, and this is the big data landscape. So to give the due credit, Matt Kirk from FirstMark publishes this annually. So this is the 2017 version of the big data landscape. And it's divided up into so many categories. You see the titles not here, but when you get a chance online. And you start to get a sense of how active and busy this space is, and what are the type of forces at play. And so basically, the thing we take away from here is that there is a new stack emerging. That new stack is driven by the forces we heard about today, which is data is what's driving this, and therefore the stack is designed at big data plus AI. So you You collect, you clean, you store, you know, process that data, and now then you run analytics on it. The goal is to go from generation to actually analytics that deliver insights all the way to action. So that's really the flow behind this that we are seeing play out here. Very exciting times indeed. What that gave me another pause was, can we predict now, looking forward, that was 2017, what's going to be happening to the AI and machine learning as a set of analytics techniques? And I thought maybe it's worthwhile looking back at another area, and the examples I looked back was databases. So I promise you we didn't coordinate, but Leo again had a chart on this thought, so I'm happy to keep seeing that we are thinking along the same lines. The point here that I'm on is databases started as standalone entities, big monolithic things. Over time, they became understood, optimized, maybe reduced in size a little bit, and you started to see them getting embedded inside of software applications. So you started to see small instances showing up over there. And then, of course, with the recent cloud wave, you see cloud-based adoption of databases as a service coming forward. So this said, okay, if that's how technologies are evolving, maybe that's the path that AI, machine learning, deep learning technologies will take. I feel it may be those things, but may not necessarily play out in the same order that it did in the past. And the reason is that cloud is here. So today, that's what Nimbix is doing. So it won't be that it comes at the end. It sort of will begin there, or right away in a parallel way, get started there. So yes, people stood up machine learning, deep learning sandboxes, standalone, to get going. But almost simultaneously, the cloud-based thought started to come up that maybe we can set this up as an API that's consumed as a service. And I believe very soon thereafter, this embedding will also be coming into prominence here. So, and just as interesting little tidbit at the bottom, you see there last week Microsoft held this data amp show, and guess what they announced? AI is going to be embedded inside of their database SQL Server. So there you have it. So that's kind of the way this industry is moving. It's really interesting to observe these forces that play in this way for the new emerging technology. So the claim from Microsoft is that ML, machine learning, and so on will be a natural part of SQL Server. That's what I meant when I said embedding inside of software applications. Okay. So that's hopefully sets up the context that we have to be looking at this very exciting field, and we get busy working on it, but we kind of step back and look at a larger picture and keep an eye out on how it is going to be influencing and get influenced by related technologies, and the end goal is ultimately how will it get consumed inside of enterprises. Let me switch gears a little bit, and I mentioned earlier that we will talk through an example. So here is an example, and the flow I have in mind is that it started out as a big data example and is now becoming a machine learning one. So there is a natural extension and connection. This is a joint exercise we have done with vendor partners, Intel, Mellanox, IBM, and Lenovo. And what's happening in here is IBM has the software. This is part of the Big Insights Hadoop Spark stack from IBM. We at Lenovo continue to work with them in developing the reference architectures, and many of our common customers are deploying that. Across the board in different geos and so on. So this exercise sort of started out by saying, let's see what we can do to turn that acceleration or the performance knob. Typically, Hadoop was thought of as middle of the pack, 2-socket 2U, middle bin CPU, just enough memory, maybe a bunch of disk drives, right? So here we are now turning on the knobs. So what you see, the goal we set was a 100 terabyte database. So this is like a TPC-DS style of pseudo benchmark, if you will. You might see mentions of Hadoop DS or Spark DS and so on. And the goal is there are a certain number of prescribed queries, simple and complex, that get thrown at this database. But you can do it with 1 terabyte, 3, 10, 30. So we went all the way to the 100 terabyte design point. And the goal was to set it up as a 30-node cluster, 28 of them data nodes. These are Lenovo servers. These are 2-socket 2Us, each of them running now. So this is where the knobs are turning. So the CPU ends up, let me back up. The way we came at this design was, Spark, as you know, is an in-memory processing engine. So the idea was that, well, if you throw more memory at it, it should be able to work better. The other idea was, instead of disk-based mechanical storage devices, let's use flash-based storage. So we went with the NVMe drives that our partner Intel enabled us and brought into the equation. So now we are talking about lots of in-memory. And in this Xeon generation, we ended up maxing out that now. So you can put 1.5 terabytes per node. There you have it. We put 1.5 terabytes per node. We had 8 2 terabyte NVMe storage device drives per node. So there was 16 terabytes of that storage. Clearly, the mid-bin CPU was not going to cut it. So we ended up going with the top bin 2697 V4 pair of CPUs there, each with 18 cores. So this is 36 cores. And as you can imagine, once the I/O bottleneck is removed, once the CPU is chugging along at the top speed, there is maximum memory available. The typical Hadoop design point of 10 gig network connectivity between these nodes got flooded very quickly. So we had to step back, and that's where Mellanox came in and said, let's go with the 100 gig switch there. So it's 100 gigabit Ethernet, and those are sort of the knobs turned all the way components inside of a Hadoop/Spark setting, but it really now gave us these fantastic numbers. You see down here, 1,008 cores, 42 terabytes of total memory in the 28-node cluster, and the storage space was available was 448. And when you divide by roughly a factor of 4, which you had to do in Hadoop because of the 3-way replication and some temp space that you need to provide, because it was able to handle the 100 terabyte data set size over there. So of course we had to then give it a moniker, and we ended up calling it the Spark F1 cluster. F1 for Formula 1. That's that little picture you see down below. What we saw out of this for that benchmark is what takes, I think, on an Amazon cluster 206, just the sorting part of the Hadoop of this exercise. 206 nodes were brought down to 28. So you can imagine power and cooling and that type of savings. Of course, it's a Formula 1. It's a car that I would like to have, but clearly it'll be a while. But there are people who really were excited. We showed off this cluster at the World of Watson conference in October 2016 in Vegas. Financial institutions, banking, insurance, some of those have these problems where they are really looking at Hadoop and Spark seriously as the next generation data management systems. And this gave them a proof point to say, yeah, they can handle the load like a traditional standalone monolithic big scale-up system would. Here is a scale-out solution. Yes, it's expensive. Maybe cloud is the way to consume it. but you know, so there was a lot of interest around this. Okay, so then we started thinking, okay, since we have Spark in there, one of the things you can do with Spark is it also has the machine learning capability. So currently some of the project work that's being driven is looking at SparkML as opposed to the Spark SQL aspect of it. There are, in fact, many problem areas. It's a, you know, certainly from the cluster design point that I mentioned here, in terms of the number of NVMEs and the network speed and performance and so on. Part of the challenge in deep learning, machine learning is the data sets. So that there would be, that sort of, it starts to become a big data problem. And we have to be thinking and planning around it. So that's the work our colleagues at the IBM Spark Technology Center are leading. We continue to push forward on this. And the problems we are trying to tackle is, as you know, training is a big challenge. Which algorithm should I be using? If I pick a set of algorithms, how should I be tuning and training those parameters? What ranges, what methods should I be using? So if you're trying to optimize, you need that horsepower to be able to go and run them in parallel, evaluate them against each other, and then be able to select the right model that comes out of it. What sort of data sets? Are they going to be realistic, real-life data sets? Are they going to be synthetic, generated locally? Are they going to be, combination? How do you scale them? How do you store them? How do you own them? That was the question that I was asking earlier at the end of Leo's talk. I think that's one thing we keep running into a lot. And so as we think about hosted, shared, sort of cloud-enabled systems, that continues to be one of the problems that it's becoming solved in ways where people are beginning to trust it, but we have to keep it front and center to be pushing for these type of architectures. So, not surprisingly, model selection is a compute-intensive problem. It is a high-performance computing problem. That's the reason there is a lot of synergy between these two areas. And I think we will continue to see a lot more research happening in this space as we go forward. So with that example, let me again switch a little bit more towards looking at these systems collectively. So I'm thinking about it in a three-pronged solution. We are trying to bring AI, machine learning, deep learning into your enterprise to put it in practice. You have to solve sort of these three components. One is the big data part, which is where you are storing, processing, cleaning your data sets, and so on. In the middle is the training aspect. So this is kind of closest to the high-performance computing. You have lots of compute requirements. You also have software that's sort of like the HPC world. You know, open source frameworks and tools are community-based, so they may get the job done 80% of the way, maybe not all the way, and you have to sort of put it together. How do you share it between different projects, between different lines of businesses who want to run their own, and so on. So it starts to become a challenge in its own self. And then the third aspect is once you have completed the training, you want to be able to deploy it. And that deployment may be distributed. First of all, training may be distributed or centralized, doesn't matter. But certainly the deployment may also be distributed. So you have to potentially think about the right size of hardware for each of these three components of the stack. And they may potentially be different. The data node designs will be driving you in different directions. So that's sort of the total workflow. And if we are going to be successful in enabling this across enterprises, then we have to sort of bring forward these a joint solution that looks at all three together. On the software side, no surprise here, you see the layered stack. At the hardware, I point out a couple of the key players at the bottom. The GPUs, NVIDIA certainly is bringing forward leading edge systems there. We work with NVIDIA. We certainly also work with Intel. And I think in one of the earlier charts, you saw both the Xeon but also the Knights series of processors. There are likely to continue to be more coming down that path. And then the layering here is telling us that you have some low-level libraries, then the frameworks, and then the programming languages, and there's a whole host of possibilities out there, a lot of it open source. So when we go down that path of looking at it open source in terms of the ecosystem, there's this similarity to HP and AI comes to mind. So I always like to play this game called Spot the Differences, like where are they similar and where are they different. So certainly there are lots of similarities. You know, how the compute for training we talked about, deep learning certainly is an HPC problem. The software looks like HPC with open source, a variety of frameworks. By the way, you may want one framework for vision problems, another one for natural languages, another one for audio and speech, and so on. So there is a lot of selection to be done there. And then the computes, engines. In my mind, one of the differences, and this might be an interesting assertion here, is that I do believe AI will permeate across the board, all applications. So this is that embedding thought of consuming it through API. So while we tend to think of HPC as a specialized compute platform or a farm or a cluster on the one side, I believe, and so that may not get distributed across the whole host of applications that all those industry verticals that I mentioned earlier are running, but certainly AI would be consumed by them across the board. So that difference may actually become a similarity in the sense that the HPC aspect of AI begin to be embedded across those applications. And this we are seeing sort of very clearly playing out as we talk to customers. So what are the challenges that we have to be mindful of? And the challenges are really at these three levels. The open source AI software stack. Maybe not for the people in this room, but for the general enterprise. And I keep saying that because those are going to be the consumers of this technology. It is a big challenge for them to be managing these collection of frameworks. They may come from different sources, they are being updated at different time scales, they are being released here and there and when. And for a given set of problems, the marketing department in the company might be looking at logo recognition, so they are looking at image processing, and there is sentiment analysis, so there is natural language processing required there. Maybe they are focusing on video streams somewhere and so on. So within a reasonably large enterprise, you might need to deploy a whole host of them. So that's certainly one problem. The other, from an architecture point of view, is distributed training, in the sense that, yes, you can throw a very big system to solve the one training problem, but when you look at it across the range of them, whether it's video or images or audio or text or sensor data or what have you, you will be needing a whole variety of systems to be able to do the required training. Not every one of those, not that they cannot be handled by this maybe sort of a big hammer solution, but they won't be cost effective. So you have to think about how they will be consumed in a cost effective manner. So that's one challenge also collectively all of us here have to help solve. And certainly the third one, as I mentioned earlier, is around making sure the systems are designed to cooperate with each other across these three pillars. and allow big data for the storage and processing, allow training, and then inference to be deployed in a common way. Okay, so one other thought along the production readiness as well. Sometimes as developers, we sort of don't want to deal with those issues because I'm so focused on my sandbox and I just wanted to make sure that it's the one that's working and being put together. Again, when we step back and look at somebody who is consuming it on the other side, they would have to care and feed those three clusters or a cluster with those three component personalities that I mentioned, that are shown here on the picture. So how do you do hardware management? How do you do firmware updates? How do you do OS deployment? How do you do a bunch of day 2, not just day 1 and day 0 and day 1, but day 2, 3, 4 type tasks in terms of monitoring and upgrade and scaling and so on. That's for the system administrators a key challenge. We are bringing in 3 different types of systems into their wheelhouse, and we have to enable them to be able to, with the right tool sets. And yes, there are tools for each of these tasks, but as they get put together, we will try to see some synergy. Open source is leading the way in many of these areas, so there is a way forward. The other challenge that I have spent recently talking to several customers, and it's not just universities which may have different departments. The physics department wants to run subatomic particle type simulations or are connected somehow with the Large Hadron Collider in Geneva, collecting gobs and gobs of data and need to be able to do some work on it. Biology people, the medicine people. So academia is full of different types of problems. You hear about hospitals, for example, research labs. They have what are known as these radiology, the PACS type systems, right? X-rays and so on. Well, that's one set of areas where they want AI machine learning to be doing a lot of automated diagnostics. But there also the scale of the problem is changing in the sense that you go from typical X-rays to really high resolution pathology slides. You see a factor of 10 to 100x increase per image in the size of the image. And if you have to train with 10,000 of them to get to the model that you're trying to arrive at, imagine the big data problem you're handling, right? So the orchestration part is different departments may have different needs depending on their application area. They may all benefit from the collection of the frameworks that are available, but we have to find a way to help orchestrate between them. How do you share the resources in the cluster in a way that lets 10 different projects run at the same time, schedule their jobs, get the right resources? Maybe they should just come and talk to Nimbix. And I'm not joking, that's really a tough problem. I know you are reliving it every day. So there are solutions available. But I think that's really the type of challenge that people are facing. And they would spend hours. I run into them. These customers come to our briefing centers, or we are at their location, or we meet up at conferences, whatever. As you start to probe a little bit, you hear about these type of challenges that are coming up. The last bullet is also not an easy one to tackle. So as you heard, you may see quotes like, what's the hottest job here? Data scientist and data engineer and so on. And there really is a skills shortage here. So it's not just a tools issue, but also a human skills issue. In March, I was in Germany and other parts of Europe talking to some university professors there. And they are actually starting degree programs to graduate more master's and PhD level workers, I guess, engineers and scientists, to be able to enter this evolving field. It may actually, in some sense, I heard sort of helping the national economy. So these are, in Europe, each country has some mandates from the government to modernize healthcare, modernize government. That even I heard in Malaysia with the e-government initiatives there in the Asian countries. So, okay, great. So now there is a mandate to go do this. You turn around and say, where are the people who are going to go do it? So it sort of comes back to solving that problem. So it's certainly going to be a very active and very vibrant area. It's sort of the point I want to make. But to this audience, all of you, as we solve specific problems, let's also keep in mind this larger context where there are some very interesting challenges facing this whole emergence of AI and machine learning. So, you can say that, well, we'll benefit from the technology trends. We heard about compute, CPU, accelerators, GPU, FPGA, ASICs, what have you. Certainly memory, NVMe flash, the I/O and networking, 25 gig, 40, 100, 50, 100, those things are direct attachment, the open capping presentation we heard. All of those are pointing in the direction of getting a lot of help at the hardware level. The software technology is also in that evolution phase, as I mentioned. And we have to be able to make it very blunt, from the pedestrian level, meaning small problems, all the way to the Formula One type problems. That's a whole range of them that would need to be addressed and solved. And besides the technology components, hardware and software, there are these other issues as a service deployment. Is this something which, how do I make it? It doesn't, and I'm saying this could be on premises. It could be set up as a service for consumption on premises. It could be set up in a hosted shared cloud environment, like Nimbix being an example. It could be on public cloud, and certainly every one of the big players has made their machine learning intentions very clear. A lot of the frameworks, the software frameworks we talked about are coming from them. And then there are some peculiarities and impediments, if you will, or at least challenges to be addressed. I talked to the data ownership one, but also the industry vertical related peculiarities, maybe. In my work with the healthcare industry, I see sort of two examples. The banking finance are always the ones leaning in. They are ahead of the game, running out, trying out new technologies, putting it up. The healthcare space is a very cautious, very careful, measured pace type of sector. So they are interested in the improvements, but they have certain very big sort of regulatory requirements that they have to live around. HIPAA over here, but there are parallels all over the world, in Europe, in Asia, everywhere. And they are driving the consumption of these technologies for us. So I think dealing with those peculiarities, privacy issues, we don't even want to go there, because there's a whole other day you can spend talking about privacy related to AI and so on. But we will have to be addressing those. So, sort of in closing, I think back to the context discussion, we are at a very exciting juncture. As we heard in the talks this morning, so much is going on in terms of technology. I believe AI will build on the big data on top of this, as we saw. It is the new sort of analytics technique that's going to be adopted broadly across the board. And then the other aspect is, which we didn't do, we sort of stopped at the big data landscape. That in itself is fighting its way inside of the enterprise IT architecture. So the Gartner has these definitions of called mode 1, traditional monolithic slow tree wall, have been around for 30 years, kind of mode 1 enterprise IT architectures, into mode 2, more agile, more open source driven, more quick on the turn, adopting new technologies, and the stability of those through the open source community and other type of cloud enablement is being proven enough that enterprises are attracted to actually go adopt them. So one of the areas in which they will be adopting that is big data and AI. And I think in closing, I would like to leave with that thought that we look at specific technical challenges and come up with solutions, but we also can be looking at how these will get adopted across the businesses, the governmental organizations, personal lives. We all are affected by AI, machine learning in a lot of the daily activities that we do. So keep at it. Let's keep at it. It's the start of a journey, at least for the next 5 to 10 years. It will be very exciting. Okay, so thank you for your time and attention. I will be happy to take any questions or comments, disagreements, allergies, whatever.
Ajay, thank you very much. And I just want to echo the fact that we did not coordinate, even though we're arriving at the same conclusion. I just think it's like you said, it's just kind of where everything is headed. But if anyone has any questions, please raise your hands, and I'll come by with mine.
One up here.
Yeah.
Very good. I think we covered quite a bit with the machine learning and
Yep.
and also cloud aspect, right? So there is a school of thought right now that's saying HDFS. We've seen it 1.0, 2.0 Spark.
Yeah.
And now AWS, S3 being a distributed storage.
Yep.
And then Azure providing the database.
Yep.
So there's a school of thought they're saying HDFS would be going away.
Mm-hmm.
And what are your opinion on that? Saying standing up HDFS clusters
Yep.
that AWS is providing at the for a searching
Yeah.
service.
Okay,
So
so
what we can do on that?
sure, yeah. I think that so there are sort of 2 layers to that question or the answer. One is that's sort of the natural evolution within open source anyway. Newer technologies are always being added on to these frameworks. I think HDFS played a significant role coming out of Google and Yahoo and so on in establishing the distributed storage architecture as a way to handle large, big, tough problems, even so much so that they are not just science experiments, but they are they are able to run enterprises' production systems onto those architectures. That is permeated across databases, across computing, across and so on. The other thought in my mind is that there is, so this is now talking to the cloud, there is the sort of pattern or blueprint, if you will, that's emerging is hybrid. So I know I'm speaking at a cloud-enabled conference, but I think as we were talking during break, it's really how people are seeing this. So what I would do on premises, certain things I have to do on premises. It may be due to country regulations, it may be due to industry regulations, it may be due to my own customers' concerns, right? So building up these systems in a way that let me do them on premises and then interface with large or small or mid-sized cloud providers is going to be the way. Yes, there may be emerging architecture, there may be some dominance of that type happening from time to time. So it'll be interesting to watch. I'm not yet ready to say that, oh, that's it, because there's usually a 5 to 10 years window for these technologies to sort of completely get overtaken by something new, right? So we are seeing the leading edge, and I agree with you, there is a lot of activity. The Microsoft model of the Azure stack is that I will have you run both on-prem and over there. So it will look and feel the same. And from the skills shortage and the tools point that I was making, that makes a lot of sense. It's not necessary, you can do it the other way, but yeah, that may be one way to go, right? So there may be lots of different business models that are evolving. Open source community is a force to reckon with, so they will keep pushing that forward. So we'll see. Hopefully that was not direct answer. Oh, anybody else, if you want to add?
Well, actually, I just want to add one thing to what you said. I think the API and serverless computing is very key to that, right? I mean, the last thing you want to have to do is have kind of an on-premises burst that requires orchestration of machines in the cloud. You want to, that's one of the reasons why we think serverless is so important. You just got to be able to run the analytic by itself, right? Yeah. So anyway, that's.
So I wanted to get your thoughts on the challenge as we look at, we've talked about this next wave of, machine learning AI, and the evolution.
Yeah.
The type of machinery we need to do this, and the adoption rates across different industries. So the question is really about how do you see industries dealing with the challenge of the velocity of change, and the investments that have to be made in infrastructure to be able to do that. And by the time you get, you're just, question on HDFS is a great question. A lot of people have deployed a lot of big Hadoop clusters, and it is the question, now we've got to rip that out and do something else. It's very hard for enterprises to do it at the pace that the technology is changing. So my question is, what are your thoughts on how we address that challenge as a world?
Absolutely, and I think it's not just technology driven, it's also business and regulatory challenges thrown in there as well. In the sense that if an enterprise is willing to invest, they may not be able to as easily because of something that might be holding back. And going back to the database versus AI example that I pointed out, cloud as a model to consume IT is now here to stay. People have been rationalizing it. You see, again, an example from my healthcare background. 5 years back, electronic health records, you would never think would leave the hospital boundaries. How can you share patient data? But now it's sitting on cloud because the ISVs themselves, like the likes of Epic and Cerner and others, are providing cloud-based software as a service for their EHR and EMR, which means what? The hospital is sending their data into their cloud. So that level of trust is rising. So cloud as a model for consumption is here to stay. The other lever that keeps going back and forth is the cost. So just to kind of address a little bit that elephant in the room, right? It's very easy to get started on the cloud. DevOps, first 6 months, you do it. You have it set up. Okay, now I'm going to put it in production. Oh wait, I need these 10 other services in order to make it fully production ready. And what I thought was going to be my monthly bill for that service is actually now getting padded up by all these other things, right? So, and then people step back, maybe then I would be able to do better setting it up in-house. Okay, let's go buy it. I just spoke to a customer last month. They bought it. They set up data science teams and clusters and they became like a Swiss cheese, kind of like a patchwork. There was no view end to end that they could realize the benefit which sort of sent them that way. Yeah, completely. So it is a state of churn, and that's why I go back to that hybrid as a blueprint that you will see emerging. There are certain areas which enterprises would want happening on premises, but they will want to limit either by function, therefore workload size, or by seasonal variations, or by workload variations, or new campaigns, and so on. They would need that connection. So their enterprise IT is really both on-prem as well as on cloud. And that's really what we have to help enable going forward. So to the extent that we can help address that, the adoption will be faster.
Any other?
My question is a little more around business value. Because at the end of the day, no matter how we look at what we're capable of doing technology-wise, The question in the business is, what is the value to the business? So I'd like to hear your thoughts on how you see that and how do you see it happening currently and now and in say next 2 to 3 years.
Right. Very good question. Think of two businesses in the same identical industry, maybe even in the same geo. One has deployed data collection systems and are continuing to use traditional methods for deriving insights. The other has done that but also added on the AI related newer, could be sentiment analysis, could be customer buying behavior, could be number of visits to the store. So right there you have it that they both have the technology, it's just a couple of these pieces are missing and one business is able to outdo the other. And again, we sort of see as we talk to customers, we see these examples. The hospitals want to make sure that they are enabling more remote patient care by having smart sensors in their home setting that are helping analysis through some of these techniques. Maybe one clinic is doing better than the other, maybe one retail is doing better than the other, one financial institution doing better than the other. So there is that awareness that new technology won't by itself just get me there. I will need to invest to make the most out of it, right? You buy the Formula 1 cluster, but you drive it at 55. What is it in Texas now? It's 90 or right? You have the machine, but you're not able to push it beyond the. So that's the interplay that I see in talking to customers going on. And so finding really meaningful ways where that value is realized is going to be the sort of turning point for adoption.
Anyone else?
Thank you. That's a good question. Yeah.
Anyone else have any questions? No? Okay. Thanks very much, Ajay.